Hello, everyone, and welcome to this final session of Entanglement, Physics, Mind, and Worlds. I'm James P. Barbieri, Program Coordinator here at the Parry Center, and I'll be your host for today. So any problems, feel free to let me know in the chat. Just a quick reminder to please mute your microphones, to feel free to use the chat to share your ideas with the group. Closed captions are enabled if that's how you prefer to view the session. And of course, this session is recorded for archival purposes, and you should receive the link to this in a couple of days. So for this session, we are honored to be joined by Dr. Vandana Shiva, who is an Indian scholar, activist, and author. Food sovereignty advocate, environmentalist, and ecofeminist, Shiva holds a PhD in physics and has written more than 20 books, including Making Peace with the Earth, Staying Alive, Monocultures of the Mind, Democratizing Biology, Soil Not Oil, and Stolen Harvest. Based in Delhi, she is referred to as the Gandhi of grain for her activism associated with the anti-GMO movement. Shiva is one of the leaders and board members of the International Forum on Globalization and a figure of the anti-globalization movement. She has worked as a consultant for the Indian government and abroad, and in NGOs such as the International Forum on Globalization, Women's Environment and Development Organization, and Third World Network. She's a co-founder of the Gender Unit of the International Center for Integrated Mountain Development and of the Women's Environment and Development Organization. Shiva has received numerous international honors, such as the John Lennon-Yoko Ono Grant for Peace, Sydney's Peace Prize, Calgary's Peace Prize, and the Right Livelihood Award, which is regarded as the alternative Nobel Prize. Today, she will be talking to us for the first half of this session with a presentation entitled Living in a Non-Local World, Entanglement Meets Ecology. And with that, I'll pass it over to you. Welcome.
Thank you so much. Joy to be with all of you. My lifetime, I've realized in working in ecology that living is entanglement. We are, after all, part of the earth, even though we've been made to think we are separate from nature. And nature is inert, raw material. In fact, nature is dead, she's terra nullius. Living is participation in the processes of the living earth. So every breath we take, we are entangled with all the plant life that gives us oxygen. Every time we drink water, we are entangled with the water cycle and the hydrological cycle. And every time we eat, we are entangled with the soil biodiversity, the biodiversity of plants, the biodiversity of insects, all of which is an ecological food web. But of course, this learning was part of my growing up, but my dedication was in the early stages to physics because of Einstein. He was the person who inspired me. And so clearly, the mechanistic worldview was so inadequate to understand the world we are part of. It was inadequate because the world is not made of separate, immutable, unchanging particles. The world is made of constant flow, constant flux, constant interactions, constant symbiosis. And we are connected and interconnected through energies, through nutrition, through water. The infrastructure of life is an entangled infrastructure, not in the typical way in which it is presented as unintelligent, but as extremely sophisticated, complex, self-organizing. So I did my MSc in particle physics, and that took me deep into wanting to do a PhD, which I did start in particle physics. But the questions that kept coming in my mind were questions of quantum theory. And I eventually did my PhD, as I mentioned, on hidden variables and non-locality in quantum theory. I'd applied to work with David Bohm but he had no fellowship. So he sent me. He said, go to my student, Jeffrey Boo, at University of Western Ontario. So I worked with Jeff Boo and did my PhD with him. And the simple principles of quantum theory that differentiated so dramatically from mechanistic thought and mechanistic philosophy, first, of course, is entanglement, non-locality, non-separability, interconnectedness, non-separation. Mechanistic thought is based on separation. First, separation of humans from nature, and nature, in each part of nature as separate, as constituted of discrete particles separate from each other. In the quantum world, there is no separability. Everything is interconnected. And I spent a lot of time in my thesis on the Einstein-Podolsky-Rosen paradox and all the later work, including constant confirmation that there is action at a distance. More importantly, the difference between fixed, unchangeable entities to potential. And that recognition that there's a constant evolving to potential. Mechanistic thought is based on fixed, immutable entities that cannot change. Quantum theory is based on potential, which is always unfolding. And because of potential, many possibilities. And because of many possibilities, indeterminateness, uncertainty, an irreducible way. That's why all the seeking of hidden variables that would somehow provide a deterministic framework just haven't worked. The mechanistic world is based on determinateness and certainty. Quantum theory is based on irreducible uncertainty and indeterminateness, on possibilities and probabilities. And because the fact that quanta could be a wave and a particle, you cannot have an excluded middle. And there is no duality, no exclusion. It's always and. It's a wave and a particle. And it's not either or. The typical thinking these days, you're either like me or against me or my enemy, or you're with me or you're against me. That rhetoric of not just dualism, but genocidal dualism that is deepening with the either or thinking. As David Bohm wrote in Wholeness and the Implicate Order, in the unfolded implicate order, space and time are no longer the dominant factors determining the relationships of dependence or independence of different elements. Rather than entirely different sort of basic connection of elements is possible, from which our ordinary notions of space and time, along with those of separately existent material particles, are abstracted as forms derived from the deeper explicit or unfolded order, which is of special and distinguished form contained within the general totality of all others. And as this lecture series, said, that David Bohm suggests that the reason subatomic particles are able to remain in contact with one another, regardless of the distance separating them, is not because they're sending some sort of mysterious signal back and forth, but because their separateness is an illusion. At some deeper level of reality, such particles are not individual entities, but are actually extensions of the same fundamental something. And non-separability and non-locality then becomes the foundational reality. Separation becomes a construct, whether it is in the way we understand the physical world or the way we understand the natural world. My own learning of the interconnectedness of ecosystems began deeply with a movement called Chipko, in which I got involved in it at the same time as when I was doing my PhD. So I'd come back for every vacation and volunteer. And these were illiterate women who had never been even to school, forget university. When I saw a forest disappear, I was so entangled with the forest because I grew up in forest, and I felt a deep pain and I felt a deep outrage. And then I heard about this movement, Chipko. So I said I would come back and work as a volunteer for them. But it was the Chipko women who showed us in our country, but globally, this was in the early 1970s, there was no talk of ecological services and ecological functions. Forests were seen as timber mines, not even as trees separate from the forest. They were timber, this much square foot of timber to be extracted and sold. But this meant two changes in the forest ecosystem. The first, deforestation, and the second, conversion of natural forests, mixed forests into monocultures. Both were leading to devastation. And it's the women who gave us the slogan, what do the forests bear? Not timber and not profits. These forests bear soil, water, and pure air. And that ecological entanglement is what ecological knowledge is all about, what indigenous people have practiced for centuries. So the same entanglement of the quantum world is the entanglement of the ecological world. The forest is not separate from the river, is not separate from the soil. And when the forests go, the landslides start, the flooding starts, the drought starts. And that's the reason the women rose. And they said, we will hug the trees. You'll have to kill us before you kill the trees. And what is a bigger symbol of entanglement than women offering their lives for the trees that give them life? And the idea, the concept of hugging in terms of protection. And then in 84, my country had two major disasters. One was in the heartland of our agricultural world where the Green Revolution was first introduced. Farmers rose in revolt, and 15,000 people were killed in the violence that was taking place at that time. And the military was sent to the sacred shrine at Amritsar. And that same year, 1984, 2nd of December, a pesticide plant leaked in the city of Bhopal and killed thousands, and people are still dying. And that's when I started to look at agriculture and ask myself, why are we using these chemicals? Where did they come from? So I wrote a book for the United Nations University called The Violence of the Green Revolution, and showed that there was an entanglement of the chemicals we use in agriculture today with the chemicals that were used in Hitler's Germany, IG Farben, Standard Oil, working together to turn fossil fuels into toxic chemicals to kill first human beings. Then they later turned it into all the other chemicals that destroy life. But because of that book, I was invited to a meeting on the new biotechnologies in 1987. And that's the meeting at which the corporations laid out and said, we have to now genetically engineer seeds in order to take patents on seed. And that's where our future profits will come. But in order to ensure that no farmer has seed, we have to create an international intellectual property treaty that will make it illegal for farmers to have their own seed. And by the year 2000, all seeds will be GMO, all seeds will be patented. And I heard this and I said, but seed is the very base of life. Seed is not a machine. Seed is not an invention. Seed has not been put together as an artifact. Seed is the unfolding of constant creative evolution, as Bohm so powerfully describes. What we have here is a kind of a universal process of constant creation, annihilation, determined through the superquantum potential, so as to give rise to a world of form and structure in which all manifest features are only relatively constant, recurrent, and stable aspects of the whole. So the seed, the tiny little seed, can become a giant oak tree. A little mustard seed can give you 1,000 seeds. A little millet seed can give you 100,000 seeds. And all that genetic engineering does is use one or two techniques to add a gene, a Bt toxin gene or a Roundup Ready gene. But the next generation of the plant is not invented by those who claim intellectual property. And these few simple things, that seed makes itself, seed is autopoietic, self-organized. Seed is linked to the soil, it's entangled with the soil. And the plant and the food we eat is entangled with the seed, its evolutionary history. So I started the movement to save seeds. And I started the movement to also not accept the illusion that humans have created life. And fortunately, in India's law, we have managed, I worked very closely with our parliament, and we would work and draft language. And our patent law says plants, animals, and seeds are not human inventions. Therefore, they are not patentable. And even more significantly, another law says, because when I was asked by the government to help draft a law on farmers, on breeders' rights, I said, but the farmers are the first breeders. So their rights are the first rights. So we recognize that 99.9% breeding has been done by peasants and indigenous communities. Just the tiny bits of transformation is what industry has done to try and then take monopoly. So the entanglement of the seed is what took me then to the understanding of organisms and their relationship through self-organized complexity. And I want to share two very important quotes. One is from Whitehead, who says, each organism in the act of prehensive unification enfolds the, like Bohm is talking, enfolds the environment consisting of others into a unity residing in a self, which, while aspects of the self are excommunicated to others. The realization of self and other are thus completely intertwined. The individual is a distinctive enfoldment of the environment, but also simultaneously delocalized over all individuals. Society is thus a community of individuals mutually delocalized and mutually implicated. And you can see the resonance, both of the language and the philosophy between Whitehead and Bohm. My very dear friend Maywan, Dr. Maywan Ho, who a brilliant biologist and a geneticist, and she started to come to me in the I think the 80s, because she started to bring together biology and quantum theory, and she wrote 2 or 3 brilliant books. One is called The Rainbow and the Worm, in which she writes that the rainbow is in the worm. All the colors of the rainbow are in the worm. And as she writes repeatedly, life in the ideal domain is a domain that captures and stores energy and mobilizes it quantum coherently in perfectly coupled cycles that generate no entropy. Schrödinger, in his book, What is Life, is the one who pointed out the amazing thing about living systems, unlike mechanical systems, is that they have negative entropy. They convert disorganized energy into more organized energy, compared to burning fossil fuels, where we constantly take the energy in the fossil fuels, the stored energy in the fossil, and turn it into wasted pollution and give us climate change. So she carries on to say, in a quantum, a very powerful phrase, quantum coherence, that at every point, in every living organism, in every ecosystem, all the way to Gaia, there is coherent transformation taking place, unique to every part of the system, and yet a resonance that becomes like a symphony. So in a quantum coherent universe, all beings are both localized as particles, solid objects, and delocalized as quantum wave functions, spread ultimately throughout the universe. Hence, all beings are mutually entangled and mutually constitutive. Thus, harming others effectively harms ourselves. And the best way to benefit oneself is to benefit others. And this is the kind of moment we are in, to look for these deeper interconnectedness between different streams of an interconnected thinking, of entanglement thinking. We are facing existential problems, multiple crises, and these are life-threatening. Individually, they are destroying life, but collectively, and they are interconnected, collectively, they could spell extinction of our species. They're already driving 20 species to extinction in the now. No, sorry, 200 species to extinction per day. But human beings, some human beings are already threatened, and indigenous people, people who are in war zones are already threatened. But the humans as a species, as a whole, could be extinct if we don't shift our thinking. And the false assumptions of the mechanistic philosophy, which is also based on the idea of separation, and with separation, the idea of superiority and hierarchies, that we are superior to other beings, the anthropocentric illusion, that some races are superior to others, the racism illusion, some genders are superior to others, the sexist illusion, the patriarchal illusion, and the false assumptions of this ideology of separation is that humans are separate from the earth, the wealth creation in the market is separate from the contribution of others, of nature, of workers, of women, of our ancestors. Actions are separate from consequences, and rights are separate from responsibility. And if you look at how, on the one hand, the mechanistic philosophy of both Bacon and Descartes, and on the other hand, its elaboration into an economic model in terms of our relationship with nature, in terms of how you use nature's resources, we have created an amazing ontology. That the soil is empty. They say the soil is empty. When I wrote my book on the violence of the Green Revolution, I read every book that had been written at that time about agriculture, the Green Revolution. And the assumption was the soil is empty till fertilizers are put into it. But my work has shown that the fertilizer, in fact, killed the living soil. The soil is a living system. 1 teaspoon of living soil contains 6 billion microorganisms, including 1 billion bacteria. This translates into 1 ton per hectare. 1 square cubic meter of soil contains 1,000 earthworms, 50,000 insects, 12 trillion roundworms. It's an amazing web of life. And the entanglement is at every level, because a web is an entanglement. But the most beautiful part of entanglement is symbiosis. That the fungi, and the soils of the Navdanya farms and farmers have increased fungi, mycorrhizal fungi, by 3,600%. And the fungi create symbiotic relationships with the plant roots. The plants through photosynthesis, and just look at the amazing entanglement of life. The green leaf is entangled with the sunshine, and through photosynthesis, transforms the carbon dioxide into carbohydrates that give us life, give us food, the living molecule, the molecule of life, and also the oxygen we breathe. And through this symbiosis, the more the fungi and the more they bring the minerals, the more they're able to put nutrition for the plants. Synthetic fertilizers actually kill the real nutrition for the plants. Food has become 60–70% nutritionally empty because of industrial agriculture and application of chemicals. And the more life there is in the soil, the healthier the food is, the healthier the plants are, and more importantly, the healthier our gut microbiome is. We are entangled with the soil. We are soil, because every time we eat food, we are eating the gifts of the soil and the soil organisms. Every time we eat a plant, we are eating the sunshine. We are eating the gifts of the pollinators. And when I started Navdanya, I just knew I would save seeds, because I did not accept the total destruction of the worldview that life is self-organized, life is diverse, life is about sharing. idea of seed as a machine invented by Monsanto was so abusive to the real world of living systems and so violent against farmers who would be criminalized for saving seeds. And my life's work has been both defending farmers' freedom, farmer seed freedom, as well as resisting any law of criminalization of farmers saving seeds. And this is happening in every part of the world, and everywhere farmers have to rise. But I was saving seeds, I just called it the seed saving movement. And I went for a collection to a very remote part of India where I knew the old seeds would be there, the heirloom seeds would be there. And I just finished my studies on the Green Revolution with monocultures of rice in one season, monocultures of wheat in another season, and that's it. And here there was a field with 9 crops. I counted the 9 crops. And I said to the farmer, wow, you're growing 9 crops together. And for me, this diversity of mixtures, pluralism, hanging together, living together was so impressive. Of course, that's the kind of agriculture I'd grown with, but not observed it in a systematic way. And when I said, wow, you're growing 9 crops together, this peasant, a tribal peasant, turns around and says, yes, Navdanya, don't you know? And of course I didn't know. I had no idea. Navdanya means 9 seeds in a literal way. But then he gave me this discourse, and whether it was the women of Chipko teaching me about the ecological entanglement between the forests and the streams, the landslides and the deforestation, or it was this South Indian indigenous peasant teaching me that the reason I'm growing 9 crops is there are 9 planets. And by growing 9 crops, I'm upholding cosmic harmony, but I'm upholding the harmony at the ecological level, the harmony of the earth. And then I am generating healthy food for my community and family. Because for me, the cosmos and the food we grow are interconnected. Our health and the health of the soil is interconnected. Again, a tribal who'd never been to school. Entanglement is the way normal human beings have been thinking. We've been made abnormal for a few centuries to think as if life is a machine, to think as if we are atoms and machines. It's a good moment to wake up again to a life of interbeing, a life of interconnectedness, a life of creative entanglement. Thank you.
Wonderful. Thank you so much for this. And thank you for bringing the element of the earth into this discussion on entanglement. I'd like to open it up now to see if there's any questions from our audience. Jonathan, did you want to come in first?
Yeah, a couple of things, if I may. Firstly, thank you so much indeed for that talk, because as you might guess from if you've seen the titles, the past few weeks we've been quite abstract, we've been quite philosophical, we've been discussing quantum entanglement at the implicate layer, but you've brought it down to earth in a very, very literal way, which I think is a splendid way to end the series that we've been doing. Can I just take you back to the right at the very beginning of what you were saying, if I may, just for a second? Because you started by giving a very powerful and clear contrast between quantum mechanics and the sort of mechanistic view of the world. But one word you didn't use, and this isn't a criticism, but just a comment. One word you didn't use was reductionism. And I was very privileged to give the first talk in this series. And one of the things I said there was that, in my belief, entanglement radically undermines this reductionist philosophy. Would you go along with that idea?
Absolutely. I actually normally use mechanistic reductionism as the phrase in normal discussion on science and epistemology. Mechanistic reductionism, they go together. Because a mechanistic view divides and reduces in whole systems, and it reduces and makes relationships disappear, and relationships where entanglement happens.
In some ways, I think it's in some ways I don't, but in some ways I do think it's actually quite surprising that some of the most strident defenders in the modern time of a mechanistic reductionist worldview actually are biologists. And you'd kind of think that their study of biology would persuade them otherwise. But we see very public figures, you know, being very strident about this. Why do you think that is?
Well, I think for that, we need to look at two things. One, that a large part of modern biology grew as part of colonialism, and therefore as a very big part of separation. But the second was the same time when the entire ideology of racial inferiority was being deepened through eugenics. And then many of the scientists of Nazi Germany moved to the United States. I think it was called a Project Paperclip.
Yeah.
By, you know, they were taken there. And then the Rockefellers jumped into this and created the idea of, I think they called it this brilliant book called The Molecular Vision of Life. Mm-hmm. And it's by Lily Kay, who looked at the Rockefeller archives. And they began long before genetics was formed, you know, long before Watson and Crick, I mean, not genetics, but molecular biology. Yeah. They were defining the atoms of determinism. Rockefeller was looking for atoms of determinism. And the idea of the gene then grew out of that seeking of a mechanistic reductionism, reduce everything to a gene, and then manipulate the gene. So out of this then grew genetic engineering. Out of it grew molecular. So, and the best geneticists who really understand gene ecology and gene relationships have been critical of that molecular reductionism. Among them is people like Maywan Hood, dear Brian Goodwin, another friend, you know, some of the best thinkers of biology as living systems who've given us, you know, comprehensive thought. They have the ones who have pointed out how biology was reduced to mechanistic reductionism. And because it then got linked to huge interests of money making and power. I've written about it in my books, but Rockefeller then pushed so hard that every Nobel Prize, after they started to push it, was given to a molecular biologist. No other field of biology even survived.
I've never heard anything like that story before. That's absolutely fascinating. Can I just ask one more thing, because I do want to pass it over to the audience, seeing as we don't have you for I don't want to monopolize you for the time we have you. One thing that we've not talked about at all in this series, and I'm dropping a hint to people, there might be another series coming, is complex systems. You mentioned emergent complexity. I think there's a role in all of this for the hugely badly named chaos theory, you know, systems that are sensitive to initial conditions. And that's a perspective I think also undermines the radical reductionist material paradigm. But would you go along with that?
And the deterministic paradigm.
Yes. Yes. Yeah. So you're agreeing with me there as well. Good. James, take over. Pass it over to the people.
Wonderful. Thank you, Jonathan, for coming in. Yes, so let's open it up as usual. You can use the raise your hand function under reactions at the bottom of your screen, or just write your question in the chat and I can read it out for you. I can see we already have a few hands up. Let's invite Richard in.
Hello, everybody. I'm coming from Calgary. My apologies, my screen and our video isn't working, but I first met, or I was in your presence at the Gandhi conference in Edmonton in 1998.
Yeah.
I understand you read, I know about you getting the Peace Prize, Calgary Peace Prize. I had a student in Kerala many years ago, 1996, who wrote about chaos theory and how it could apply to a project with indigenous farmers and protecting their, which is really quite a brilliant little essay from a student. I have another student who wrote about the quantum leap in 1989 in the area of social work. Our University of Calgary, and this is my point right now, has decided that its next sort of big vision is a quantum city. And I have said to the dean of my faculty that get on that wagon and don't let the other kind of, if you want, hard scientists think that this is their territory. It belongs to all of us. So I'm just kind of wondering, what kind of advice or consultation might you give to the president of the University of Calgary to make this quantum city idea something really on the leading edge of change?
So, you know, I laid out at least the 4 principles that for me have been guiding principles of a quantum world. And if they are brought into the world of community, of society, of designing cities, then first would definitely be to recognize that, you know, we don't build the city like as if it was just blocks of a Lego. We build it like a living system in interaction. Second, that we enhance the potential for both the natural system in the city as well as the human system to be able to be nicer people. And I would then add diversity as a key aspect of the design. And definitely, you know, I have watched my country, you know, from being self-organized local communities, producing everything they need, beautiful markets, you know, making the most beautiful clothing for local use. And then with globalization, all the strange laws come. Making your own food with your hands is illegal. You must have toxic food made by, packaged and, you know, by Pepsi and Coke and Nestle. And that becomes safety. This becomes unsafe. Mixed use is the most important part. It's called quantum coherence. It's the most important part of a living city. And then the separations start, and no urban areas have to be divided into commercial areas, into residential areas. And then you start destroying livelihoods and you start destroying community. So bringing diversity as the no excluded middle, no one excluded, these principles are totally applicable to designing cities.
Thank you. I hope in the recording I might be able to take that message to the president.
Thank you, Richard. Next, I'd like to invite Mary.
Thank you. I really just want to express my gratitude to Vandana Shiva, to this whole program, but to Vandana Shiva, and to say explicitly that there's something in the emanation of your human expression that is so moving. And I've experienced this many times in taking in your message through your particular human self. And so I want to ask, I guess, or if there's anything you want to say on a personal level about, and I don't know if personal is the right term, about what allows you in particular to carry such a generative Shakti, positivity, life-affirming bearing in at the same time that you're expressing such dire messages. So anything that you can share about that would be really appreciated.
Yeah, you know, you use the word Shakti, which is the generative power, the creative power of the universe, but also, you know, particularly in feminine embodiment. You know, my life really has been a life of relationships and responding with love and care, whether it was a forest or a river or a seed or food or human beings. And So in a way, one could say that our humanity comes from entanglement, being related, knowing we are part of it, and my life's experience has been that when you're not working from an ego, which is about a separated self, but from the ecological web of life, and you're speaking for the soil as the soil, you're speaking for the seed as the seed, you're talking about the indigenous people as part of them, the child who's being denied health and denied food today, then you start living that entangled world of both the shared pain as well as the shared potential to create another world.
Thank you, Mary. Next, I'd like to invite Cynthia.
Hi, this is Cynthia, and my name is Tom Cavalli, and I have a question, a couple of questions and a comment. First of all, I appreciate your presentation. It speaks to me particularly in a professional, personal way, because I am a psychologist. I'm a Jungian psychologist, and I teach and write about alchemy, which of course is kind of an acronym in today's modern lexicon, but to me, it has tremendous application in what you're talking about. It brings me back to the work, the collaboration between Wolfgang Pauli and C.G. Jung, who were trying to develop a not just a collaboration, but a new language, which I think is sorely needed. Some of the premises I think that make this the creation of a new language so difficult is this whole difficulty between what in physics oftentimes is referred to as the hard problem, and that's consciousness. And I think that's such a difficult obstacle because consciousness is ineffable. It's hard to measure, and when you try to measure it, it's very elusive. In my work, I'm approaching it from one angle as a Jungian psychologist, and I give talks about alchemical psychology, and that approaches this issue of developing a new language from one position. And much of what I've heard throughout this series approaches it more from the physical approach. But I don't see anyone, or maybe you can suggest someone, some writers or researchers, who are taking the third position, a much more integral position. Without, I mean, it's a very difficult balance, between philosophy and physics. But I think without that new language, we're always going to bring this bias, this lens through which we're looking, and we see what we want to see. And it's in the blind spot that I think to use your word, hidden variables lie. I'd also like to hear a little bit more. You mentioned this indigenous farmer in South India. And by the way, alchemy, as you may be aware, believe it's called rasa in India. And when I use that word, it's really the gateway, the portal to a new language, because it's the integration of psyche and soma. And I'd like to hear a little bit more, if you could, about the 9 plants and what, if you could elaborate more on that, because this farmer understands the interconnectedness, the union of those, that position where psyche and soma are not separate. They are part of a greater phenomenon. And Jung uses the old Latin term unus mundus. So what this third language requires us to take a third position rather than an egocentric approach. It's kind of like, how do we approach it from the position of objective wisdom or objective intelligence, as Jung calls it. So if you could comment on that, I'd appreciate it.
First, because every ecosystem is different and plants are different. The 9 plants, the 9 seeds vary according to what particular climate will grow. But what I've noticed is, I wish I could find this for you, but you know, this beautiful mandala of, you know, the 9 spheres, which is actually at births, and as after I was taught by this tribal peasant, I found it was all over the place, you know, but you don't see things if you're not looking for them, yeah. Your eyes are not open to it. So it's always a balance of protein crops, you know, the dals, cereal crops, and oilseed crops, because you need that diversity in your nutrition.
Oh, okay.
And when I was talking about the entanglement, you know, between us and the earth, not only because we are part of the earth, but because the state of the soil, the health of the soil, the biodiversity of the soil determines the health and biodiversity of our gut microbiome. And just in the last decade, they're starting to find this out. But not just that, that so much of the neurological functions are regulated by the second gut, you know, by the second brain. The gut is the second brain. And the attack on the gut is one reason why, you know, when I was a child, every old person could remember a history of 300 years, their grandmother and their great-grandmother, and what happened to India this year and what happened to India. And now every second person has dementia and Alzheimer's, you know, what has shifted? And that's basically the dysfunctionality, you know, the disruptions in our relationships. I myself don't work on psychology, but I think the idea of coherence, of self-organization, of complexity as harmony that's working non-locally all the time. That, you know, when I speak, I'm not an Ayurvedic doctor, I know nothing about it, but when I talk about the fact that I understand how Ayurveda as a system science can heal the whole body, you know, they get a lot of confidence, because the mechanistic science of the big pharma is constantly attacking them. And of course, you know, manipulating the brain, you know, look at the amount of psychiatric drugs that are being sold now, you know, simple facts like zinc deficiency, when the soil has no zinc, food has zinc deficiency, depression, magnesium deficiency, attention deficit. These are all scientifically established. And our work, our research, you know, that's what's so exciting in the work we do in Nadanya. The zinc has gone down 34% in 20 years of industrial farming in our valley, and it's gone up 14% in the organic farms. And this, you know, so the deficiency that are an assault, because our mind is not separate from the body. I mean, Descartes, the arrogance of saying, I'm a thinking thing without a body, you know. Can you imagine a thinking thing without a body? What kind of world they will create, what kind of paradigms they will leave us with. And therefore, you know, I think we need a convergence of all the streams of thinking beyond mechanistic reductionism, and then look at the common patterns that are emerging from all of them.
You also mentioned Bacon. I'm sure you meant Francis Bacon, and I think that was
father of modern science.
Yes.
Reason the Royal Society was created.
Right. And I think that was a pivotal point, you know, to use Buba's term. I think that the attitude, you know, towards nature turned from an I thou position to an I it position. And that's the critical pivotal point.
Yeah.
Thank you. Thank you for coming in.
Thank you.
Next, I'd like to invite Todd.
Well, first of all, thank you for all of your contributions today and your life's work. I'm curious, on all the battles that you have fought on all the different fronts over the decades, where in your heart of hearts do you feel the momentum is going? I mean, within capitalism, there is now shareholder revolt and accountability. Do you see the hegemonic power of Monsanto growing, being attenuated, or have we crested a wave, or where are you at when you see on the front lines?
Well, you know, I can tell you this, that when we started to question patents on seed, I think we were literally 4 of us talking to each other. And now there are hundreds and thousands and millions of people who say no patents on life, no patents on seed. When I did the book on the Green Revolution, and then we started to build the organic movement, we were a group of 7 who put together the National Organic Movement in India. Today, there are millions of farmers all over. So when you say, where's the momentum going? Quantum uncertainty. 2 possibilities. You know, Monsanto disappeared, was absorbed by Bayer, and now Germany is behaving exactly like the US government used to behave because the lobbying powers are so big. What I find as the most dangerous part right now is the GMOs of the first generation have failed, but they are now trying to sneak in gene editing, gene-edited GMOs, and then pretend that they are natural. So there will be no labeling, no one will know, no one will know the difference between organic food and manipulated food. But the next step, which to me is something everyone should take on, the idea that food is a luxury. We should have farming without farmers and food without farms. This is Mr. Gates' dystopia. And of course, Silicon Valley and Gates has such huge money that they can put it in every newspaper, in every magazine, and also even create clubs there where people really are going crazy. So, the epic battles have always been between truth and falsehood. But now it's coming down to materiality, real food and fake food, real news and fake news. It's coming into our everyday lives. And when you say, where do I find, I think in different languages, in this series, we're talking about entanglement, but I think interconnectedness is the shift, and it's happening on a very, very big way. And we don't know when it'll create enough of a popular consensus for, as Thomas Kuhn wrote so clearly in his book, The Structure of Scientific Revolutions, old paradigms don't die because they've been proven false, because within that paradigm, everything reinforces the paradigm. He says old paradigms die when a new paradigm has more power. And the old one fades away. So that's why creating new paradigms is such an important part, because how you look at the world is how you relate to it. And that's why, I spend time with you all, even while I save in my real life seeds and grow real food. And I'm in the middle of a celebration of Diverse Women for Diversity, 150 women from around the world and in India, celebrating their diversity and their power right now.
Thank you, Todd. I'm just a little conscious of the time. Are you happy to take maybe one more question?
One more, yeah.
One more. I'd like to invite then Abayomi, who we haven't heard from yet in this series.
Thank you very much for the opportunity. And thank you very much, Dr. Shiva. Can you hear me well?
Yeah.
Thank you. Yes. I was quite fascinated when one of the contributors spoke about Shakti. I also recall that in the story you told us about women who were going to embrace the trees in protection of the forest. And you've just spoken now about groups of women active along the lines of diversity. What do you subscribe to the saying that women are closer to nature in themselves, in which case they will be more sensitive to the kind of things we're talking about today, entanglement, interconnectedness?
Yeah,
that's my question.
I don't see the issue of women being closer to nature in any mechanistic way of essentialism, that they're closer to nature because they're women. Now, what happened with colonialism, what happened with capitalist patriarchy, The men were pulled out of their communities to work in mines, to work in plantations, to fight in wars. So who was left to continue the economy of life? Bringing up the children, growing the food, taking care of old people, regenerating and reproducing in social reproduction. And particularly, in all societies that are non-industrial, everyday production is with nature. I talked about my sisters with the forest, but every peasant, most farmers of the world are women. What do they work with? They co-create with nature. So they're very deeply aware of the disappearance of biodiversity. They're very deeply aware of the desertification of soil. So because of division of labor, women were left to work with nature to provide the needs of the society and community. And in societies where men were not pulled out, in some indigenous societies where industrialization did not split the labor in that way, men and women have the same intimacy, because they have the full awareness, they have paradigms and thinking that we are part of nature. It's simple as that. We're part of nature, not separate from nature. And taking care of nature is taking care of ourselves and our community.
Wonderful. Thank you so much for coming in. Now I'd just like to bring it back to you, Dr. Vandana, as I know you need to leave soon. So I just wanted to see if you had any final words to conclude this first half of this session.
Well, a lot of people who continue to think mechanistically, including a lot of environmentalists, they are going into this terrible, depression and hopelessness, because they're taking the trajectory of the linear trajectory and mechanical trajectory of the destructive trends of our time. And there are two reasons why that is not justified. The first reason is they're still thinking that it's all about human beings. And it is rooted in both an anthropocentrism, but an anthropocentric arrogance, that it all rests on us. No, living systems are bigger. We are just a web, a strand in the web of life. And the power of understanding living systems allows us to see their self-organization and their creative potential. I mean, think of the fact that this planet was 290 degrees centigrade and its living systems in the biosphere, because the biosphere is entangled with the atmosphere. We came down to 13 degrees. We are going warm again because destructive forces are destroying the biosphere. The climate discussion is really about the biosphere and its destruction. And think of the fact that that biosphere, the power of the green leaf to pull out carbon dioxide, could take a 98% concentration of CO2 and reduce it to 0.03%. And when we shift our mind to seeing that we are part of a larger whole, not only do we become more conscious of not causing harm, we also become more hopeful that we can be part of a creative regenerative process. But the second reason why I have no time for hopelessness is because uncertainty gives us the possibility of cultivating hope.
That's wonderful. What a great note to conclude this. Thank you so much
Thank
for
you.
joining us and for taking the time and to give us this inspiring, passionate presentation. So thank you so much.
Thank you. Thank you all. Bye-bye.
Thank
you. Thank you.
So now we have together another hour, which, as we have this time, we wanted to sort of take the opportunity to reflect over these past 3 weeks that we've had together. We had the first weekend where we had Jonathan giving us an introduction to entanglement. We had a few lectures looking at the pure physics with many equations, which I know some got scared from, but I hope that you all managed to grasp the concepts. We got to see some of the practical consequences of entanglement when we were discussing quantum computing. And of course, this weekend, we looked at more of the philosophical implications of entanglement. So to start off this reflection of what this series has brought forward, I'd like to invite the chair of this event, who we've heard from already, Jonathan.
Firstly, I'd like to say what a privilege it's been bringing these people together to do this. And I'm so gratified that it seems at least some of it has struck a chord with the people who have attended and watched these talks. One question came up on Sutra recently, and I entered an answer, or my own perspective answer to it. I'd just like to reiterate it here, because it might be a theme that we want to develop a little bit, or we might want to reflect further on what we've just heard now. Are hidden variables, you know, has the work that's been done effectively killed off the notion of hidden variables? Well, I just want to take us back a little bit to why the idea of a hidden variable theory was first mooted. And that was this underlying quantum randomness that we see. That when the state or the wave function or the amplitude, whatever term you want to give it, they're not quite interchangeable, but it'll do. Whenever that collapses at a moment of measurement, this deeply mysterious thing that we don't fully understand, why it is the act of measurement takes all those potentialities and makes one of them manifest. The one that is chosen, the one that is made manifest, that is random. We cannot predict in advance. We go back to this idea of spin. Then if we measure the spin on a vertical axis, we'll either get spin up or we'll get spin down, and we don't know which it will be. Now, generally in physics or in other subjects, when we're talking about randomness, we actually mean we don't know enough to predict, or we mean that the system is too complicated. There are millions, billions of particles involved. We can't do the math to effectively calculate what the possibility is. We don't mean either of those two in quantum theory. The reason it's random, the reason one or the other is manifest, is because there is no physics that determines which one it will be. There is physics that determines the likelihood of each manifestation, and that's the amplitude and its evolution. But there is no physics that determines exactly which one becomes the chosen to be manifest. And Einstein and others really couldn't tolerate this philosophically. So there was this mooted idea of a hidden variable theory, which was physics underneath quantum theory. And if we only understood that physics, we would be able to do the calculations which will enable us to predict. So what Bell did was take the notion of a hidden variable theory and show that it could be tested, that it could be held up as a rubric against nature. And if we had a hidden variable theory that successfully mimicked the predictions of quantum theory, then would it actually hold up against nature? And what Aspect and Clauser and Zeilinger have done is they've produced experiments to show that nature violates these limits. That if we have a hidden variable theory to replace quantum theory, then it has to be non-local. It has to be such that some signaling or some interconnectedness must happen faster than the speed of light. And I think most physicists regard that as too high a price. So the answer to the question, is hidden variable theory dead? No, it isn't. Hidden variable theory has not been killed off. What has been killed off is a local hidden variable theory. If you want to have a hidden variable theory, then by all means go for it. But the problem is that most physicists think that the price you need is too big a price to pay to replace quantum theory with a predictable theory. If such a thing even existed, we don't know. Should we go looking for it? Is that this non-locality would have to be baked in an unacceptable way in the modern thinking. So that would be my answer to that. And I don't know if that helps kick off a conversation or whether we want to focus back round against on what we've just heard. But I don't want to natter on any further. Let's open it up.
Thank you, Jonathan, for your your reflections. Yes, let's open up this discussion to everyone. Again, same rules apply. Use the raise your hand function, or just write in the chat, and we can start from there. Let's bring in Niels.
Thank you. I know you're against my ideas. You're saying that computation can't do this, but I can prove you wrong on that score. But that's not what I want to push. But I'm saying that, and that is actually a reductive process. But it's a reductive in the sense it works in the opposite direction of the way we live, the way we progress. And that is a creative entanglement. It creates any necessary pathways for the system to be optimal. And we know the speaker, she actually finished off saying creation entanglement. That was her very last word in her speech. And she talked about fungi. We also know about The Entangled Life by Mervyn Sheldrake. He pins out how the microorganism can actually act intelligently so that they can use it to model a complex road networks. They have used it for that, so I think they can use that. So where I come from a completely different perspective. I've done computation for about over 50 years, and I have worked in the sphere of transportation at all aspects of that. Also modeling, and if anything is entangled, it is our road system with all these entities that are milling around and interconnecting, interacting with one another. And so I would love to have an opportunity to present this transportation idea, because I think it's important. And we talked about quantum computers. My question is, do we need quantum computers? We don't. If we have the right algorithm to do the calculations, we don't. And it will take me too long to explain in detail how it works. But I offer my free participation in doing a presentation of that, and that could change things.
Thank you.
And that is we had let me just say, Emily Adlam talked about the all at once, and this algorithm is an all at once algorithm. It just chases out all the possibilities. It doesn't look at the problems. It finds we call that least action method, in a least action field that operates in the Bohm's potential, quantum potential.
Thank you, Niels. Jonathan, did you want to respond?
Without hearing a lot more about the idea, it's hard to respond particularly, and I would be interested to hear more. But just taking up on the point about, do we need quantum computers? That's an interesting one for me, because although I have an interest in the quantum computer, it's not so much because of its computing power, but what it's doing in terms of developing technology that allows us to investigate quantum theory. In the conversation with Latore afterwards, there is no proof as yet that quantum computers will be better than ordinary computers right across the board. There's no establishment. We know that there's some particular tasks they will be able to do better. And it's kind of worry about those particular tasks, which involve factorizing prime numbers, which is the key to encryption, as people know, That's what's caused all the money to be thrown at quantum computers, I think.
Yes, yes.
What they are doing is developing amazing technology that allows us to hold quantum systems in a quantum state, hold back the environment from getting in the way. And it's the chances to do experiments in quantum theory that I really am excited about on the back of the development of quantum computing.
Yes, yes.
Thank you.
I understand that. But this, what I'm talking about, is below. It is actually underpinning quantum mechanics.
Right.
Because it can find all the relevant pathways, however it entangles, it can solve that problem completely. And it's complete in that essence. But I know everyone says it's impossible. But on the face of dystopia and crisis we are in at the moment, this would be what could solve that as a third attractor. As there's a person who's talking about this, and he called it the third attractor is what we need to resolve all this. And that third attractor has to be a super intelligence, so to speak. And I believe that this is what we are talking about. I'm willing to give a talk on this.
No, noted. Yeah, we've noted.
Yeah. Okay, thank you. Yeah.
Next, there was a question in the chat that you might help with, Jonathan. It's what is the contribution of the 3 Nobel Prize winners in relation to Bohm's hidden variables theory?
Firstly, before I make too much of a comment, is Basil in the audience?
I believe not.
No, he's not today.
Okay,
No.
shame.
You can speak your mind.
Firstly, just to pick up the one point about Bohm's hidden variable theory, and that's why I wanted to know if Basil was here, because obviously he's far more expert in this than I am. But I think, thinking back to our conversation after his talk, I raised the point, but Bohm regretted it being called a hidden variable theory, or regretted initially calling it that. Because it wasn't so much a hidden variable theory, it's more of the variables playing hard to get theory. It was the theory, what generates the unpredictability in Bohm's initial theory, and we're talking here about the initial way in which he manipulated the Schrödinger equation in a very clever way to give rise to the quantum potential, or to expose its presence, probably a better way to put it, is you couldn't know the initial starting point and velocities of the electrons well enough to be able to predict which path they went through. And so that's what gave it a sort of uncertainty, hidden variable aspect, that the hidden variable was, in a sense, not being able to know the exact position and momentum of the particle you needed to make predictions. So it wasn't hidden so much as hard to get. And I think he regretted calling it that. But sorry, remind me what the second part of the question was again, James. I'm sorry.
That's okay. No, it's
the contribution of the Nobel Prize winners. Yes. Okay. So Bell did these calculations that placed a limit on the amount of these correlations you could get. Take it back to the initial idea. You generate a pair of particles in an entangled state and you fire them off in opposite directions. And you measure one of them at the station called Alice, and you measure the other one at the station called Bob. Why that we've called them Alice and Bob now? It's part of the zeitgeist. I don't know, but we do. And and Bell made these calculations to show the extent to which correlations between these two measurements could kind of happen by accident, or at least happen if there was some theory that set the particles off in a certain state to start with, that hidden variable in there, and then they interacted with the two measuring devices in their separate locations. And Clauser, and then Clauser, Horn, Chamonix, and I've forgotten the person involved, they changed Bell's calculations and produced a more readily testable version of it, which is the one I showed in my talk. And then proceeded, I think in the early 70s, to start to do the experiments. And then Alain Aspect came along, saw some of the limitations of those experiments, developed it further, technology had improved, They managed to use a better source of photons, for example, and they managed to change the settings of Alice and Bob while the photons were in flight. And that was an important development, because there was always the possibility that some communication between Alice and Bob and the starting point was sort of going on in the background. And if you like, Alice could sort of say to the thing that was creating the photons, my angle is this, make sure you're ready for that. But if the angles that they were measuring were changing while the particles were in flight, then that aspect was completely ruled out. And then Anton Zeilinger, you know, has worked in many areas. I primarily know his work due to the fact that he was investing in the wave particle duality aspect that we've heard about today already, and demonstrating that increasingly large molecules could actually show wave-like nature. And we've seen it with electrons, we've seen it with photons, but they've now got experiments whereas a molecule with thousands of atoms in it can be shown to have a wave-like nature. So that's certainly part of what he's been doing. He's also been working on extending the distance over which the entangled measurements have been happening. And he's been working on a whole, I think he was one of the signatories, or rather one of the people on the paper. Remember, I spoke about the situation where they had two quasars, these very distant, exceptionally bright galaxies, using the light from those to set where the angles were. And that was certainly one of the experiments that he had a hand in as well. So that's the work that they've been doing, just taking Bell and Bohm's ideas and tightening the noose experimentally, progressively, but also developing the quantum technologies now that enable us to do these really exciting experiments that we can do, testing out quantum theory in ways that were just not conceivable 30 years ago.
Wonderful. Thank you, Jonathan. I can see Ella has her hand up. Would you like to come in?
Sure. I thank you for the wonderful opportunity, everyone, for to be here. And Jonathan, as an educator, I just wanted to tell you that I think you do an excellent job of breaking down the material and presenting it, and it's very understandable. So just from an educational perspective, appreciative of that ability.
That's very kind.
Thank you. And of course, very appreciative of Basil and Emily, and of course, David Bohm, and who is really why I'm here, who I learned about a few years ago. And Vandana as well has brought in the environmental and the biological, and I love that aspect. My question is not so much on quantum physics, but on application of what we do know and the fragmentation in society as it is, particularly in the US, and but all over the world, actually. How do we apply what we know when, as Bohm often said, we need to suspect our own thought process? It's fragmentary, and it's by definition limited and conditioned. All our conditioning goes into each and every thought that we think. And so how do we get out of that trap, as it were, and incorporate all this knowledge that we have and not behave in such fragmentary ways, and provide for basic needs in our own countries and around the world. And because that seems to be necessary, there seems to be a foundational need, a network there for everyone, and not just some particular groups, but everyone. And the brightest among us can't seem to see the need, or apply what they know, and are very divided in their own perspectives. Thank you. Any comments? Appreciate it.
I'd like to throw that open to far more than just myself, because I've not got an immediate answer to it, but I'll make 2 comments. Firstly, this kind of came up also in the conversation with Vandana afterwards, because I was reflecting that one of the things that does kind of worry me most about society at the moment, albeit there's a lot of things to worry about, one of the things that worries me personally most is the growing science skepticism, the growing distrust of science amongst political figures, if nothing else, or at least the outside rejection of science amongst political figures. And I'm not sure how we tackle that. I'm not sure how we tackle that, but that does worry me deeply. But also, you know, we are tackling it right here, right now, by being part of this group. I think would be my, albeit very inadequate, suggestion that, you know, if these groups grow and we talk to other people, we bring them into the entanglement that is this group. And I'm conscious of as a physicist here, that we're using the word entanglement slightly metaphorically and not exactly the way it's meant in physics, but that's fine, as long as we appreciate that. And if we are bringing other people into our entanglement and that is spreading, then that might be a way in which we can actually start to counter the powerful flows that are going in the wrong direction. But I'll just add one more slight bit of hope. It's come up yesterday. It came up, and actually, Dean, I don't know if Dean's still out there, but Dean mentioned the Global Consciousness Project, and you know that is a project I think this group would be interested to hear more about on another occasion. But if you recall from what Dean was saying yesterday, if the Global Consciousness Project work holds up, and I think there's good strong evidence that it does, then there is a kind of shifting global consciousness, and the very fact that we are here engaging in these conversations might ripple out in ways that we don't fully appreciate. But that's a very inadequate answer. Someone else help me out, please.
Thank you, Ella. Next, let's invite Philip.
Yes, hello. I think this relates to the last question and part of your answer, which is the issue of words available in the English language, at least. I'm more at home in biology than quantum physics myself. And thinking back to Vandana's talk, she used interconnected, which for me is too hard, mechanical a word for what she means. Interfused or interfluent might be better there, but that doesn't take in light and energy transfer satisfactorily. So we kind of lack a word there for what's really meant by interconnected in terms of biology. Entangled is maybe slightly less bad, but even that's it conjures up strings and not fluid moving things. And in subatomic physics, I think particles is problematic, and you probably agree with me there. And I've always thought that we need to think in terms of morphodynamics or kinemorphodynamics. That's movement, force exchange, and form, all interrelated. But what I'm hearing about quantum physics and action at a distance, entanglement, it goes beyond that. It's more to do with information or meaning we just don't have a word. So I really wanted to raise that problem of the limits of language, and that we ought to be more careful, actually, particularly as biologists, the way we talk, and not to use structure and mechanisms. They're almost ubiquitous in biology, that you talk about the structure and the mechanism. It should be more like the dynamic fabric, and processes is less bad than mechanisms, but still not quite adequate, I think. Anyway, that's my comment to this discussion.
I personally, I think it's a very, very fair and difficult point. I mean, I seem to remember reading some research or coming across some research many decades ago, which suggested, and I wish I could find it now to check whether I'm not making it up, but to verify it, but that people who were language speakers, Oriental language speakers, had less difficulty with quantum theory because their basic language was more relational, more picturesque, more I can't think of the right phrases to use, but and there is someone helped me out, psychologists as well, because there is a psychological theory, is there not? I want to say, I've forgotten the name of it, but your language influences your very way of thinking. There was a brilliant science fiction movie called Arrival, based, is it Sapir-Whorf hypothesis or something? But that your language influences your very way of thinking, and if you can change your language structure, you can change your very approach to thinking. So yeah, we are, and this is something the Bohr talked an awful lot about. We are limited by our language. Bohr, in a sense, turned it round into an advantage, because he believed that the quantum theory should be explainable in ordinary language, and so he invented this idea of being able to hold two ideas together in juxtaposition, because neither of them was completely right. But if you held them both complementarily, then you could glimpse something near the truth. So I think, yeah, there's a lot of work to be done in that area, and maybe we need to go back and, well, I need certainly to go back and reread David Bohm's chapter on the row mode in Wholeness and the Implicate Order. But again, I fear I'm treading in areas where I don't have the expertise, and I wish some more the psychologists in the audience and linguists would dive in here and help me out. But I mean, again, just Basil, of course, says he runs into this problem all the time because the mathematics is clear. The problem is that translating the mathematics into the language to make it accessible. I'd like to have that conversation further with him, because I do wonder how much our linguistic structure limits the concepts that we're trying to express in the mathematics, not the other way around. So there may be a bit more of a feedback loop going on there than he initially expressed.
I'd just like to come back with another thought, just to throw it, not really a question, but I also knew Brian Goodwin and Mei Wen Ho, and they were both influenced by the scientific approach of Goethe, or Goethe and Schelling and Alexander von Humboldt and others. And Goethe, in his essay on the experiment as mediator between subject and object, he really emphasized the importance of not having a hypothesis, but doing multiple experiments and making it also implicit that's multiple observations and letting the phenomena speak for themselves, but withholding your theory, withholding words, in fact, and let the phenomena speak to you. And it's very difficult to do that if you immediately bring a word or a concept. You're kind of inhibited from taking in all that's available. That's my comment, and I think that's very,
and kind of hinting at that possibly slightly yesterday when I made the comment to Dean about how exciting it must be to work in an area which is not theory dense. You know, that there is no well-established or in any way agreed theory, and so we can just go off in any direction and just look and see what's out there.
Thank you, Philip, for your contribution. I'd like to invite Saad in yet next.
Thank you. Can you hear me?
We can, yes.
Okay, great. So this has been absolutely fascinating on many different levels for me. I just wanted to make a comment. Perhaps I'm more on the right brain side of things, as per Ian McGilchrist's work. So for me, I'm much more about the poetry and what this means in terms of how to better understand and appreciate the world that we live in. and perhaps the meaning and the purpose of life and what it says about that. And I am a student, I'm not a scientist. I've studied a fair amount of theoretical quantum physics, but I'm very much been a student of esoteric philosophies and schools of thought, be that Eastern and Western. And the one thing that I keep coming back to about what entanglement says about us, obviously, is just the nature of how incredibly interconnected we are. It goes back to David Bohm's work of implicate order, explicit order, but also a lot of what Krishnamurti talked about. And I can see now why Krishnamurti and David Bohm were such good friends. One philosophized about it and the other put it in a mathematical equation. But when I think about in terms of the impact and the effect and where the evidence lies for profound entanglement, you really don't need to look too far other than the relationships very much around you, and ask any parent of a child or ask any twin, or for that matter, ask any couple that's been married or divorced for that matter, that and what entanglement means, and you're entangled pretty much forever. And so I just had more of a comment back or a question back to the audience, really, just as you think about the concept of entanglement, what it says about us. I kind of, I go back to a very old Zulu saying, which was Sawubona, which means I see you. And I see you because you're there, because I'm here, and we're one and the same. So I see you, I recognize you. And that sort of, pretty much culminates all the theories and into one sort of neat little poetic little phrase. But it's really just a question back to Jonathan, if you can put it perhaps some more into poetic terms, or just what it says about the nature of humanity and how we should really look to behave and interact with one and each other, and what it could say potentially about the future.
Awesome responsibility to try. My initial comment actually is a little bit more prosaic, if you'll forgive me, which is to point out, if people haven't discovered it, a rather excellent book, which I'm glancing off camera to see if I can quickly grab it. But it's a book by Ken Wilber, and I believe it's called Quantum Mysteries. And it's one of my all-time favorite books, because what Ken Wilber has done there is he's taken fairly extensive quotations or chapters from the founding fathers. I'm sorry about the implicit gender bias. I got in trouble with my publishers when I used the phrase founding fathers in my own book on quantum theory. But regrettably, the most movers and shakers in the particular areas I'm interested in were all men. Anyway, the founding fathers of quantum physics, things like Einstein, Planck, Eddington, others, and he's taken their philosophical, spiritual views and put them into this book and woven his own interpretation around them. Heisenberg is in there. I wish I could lay my hands on it. I might go look for it for a second. Who's got it holding up in front of us? Quantum Questions, is that the phrase? Is that the correct name?
Yeah,
that's it. Sorry.
Patrick
yeah, if you've not read it, then I strongly recommend it. That's the book. Thank you so very much, sir. It's certainly the case that a lot of the early pioneers of trying to fight their way through to quantum theory were of a mystical or spiritual turn of thought. Schrödinger was very, very learned with regard to the Vandanas. But I don't think they got to that through quantum physics. And I think that's the point that Ken Wilber makes. They were of that mind anyway. And maybe that enabled them to approach quantum physics in a certain way. I don't know. And I don't think it was actually their engagement with quantum physics that actually turned them to this mystical approach to things. I think it was kind of baked in by being naturally curious about the world, and maybe it gave them an angle and a perspective on it. So I'm a little wary of some of the work that's been done. Myself, as a young man, I was heavily influenced by Fritjof Capera's book, The Tao of Physics. I know that's a name that's come up already in the conversations. and I'm very sympathetic. Let me be clear. I'm very sympathetic to the esoteric philosophies and the wisdom traditions, but I wouldn't want to justify them based on quantum physics, because I think that's kind of putting the cart before the horse. But it's also running the risk of, you know, what happens if quantum physics in the future does become replaced by something else? Are we then saying that, oh, the mystical philosophies were always wrong because you've justified them in terms of quantum physics, so now we've got to unravel them? I picked up on something that Dean said the other night, and I don't know if Dean's again still in the audience, but when I asked him the question at the end, he was saying that, you know, he's an empiricist, and so he likes to do experiments, etc. And I'm sort of taking the same view about quantum theory, that I like the experiment. I'm more of a theorist myself, but I like the experiments. I like to see how nature is actually behaving. And that makes me take, not to justify the wisdom traditions, but it makes me want to engage with them more, because I'm seeing hints in my quantum theory about what might be the sort of universe that we live in. I don't want to go on too long, but I also mentioned in my first talk that I was very privileged to get to know, have lunch with, have many conversations, well, a number of conversations with John Polkinghorne, who was a very, very distinguished physicist and went on to be a distinguished theologian as well. And one of the points he always made was, we're entitled to have a consonance between our physics and our world. And when the Newtonian paradigm, which is obviously still very prevalent in many areas, when it had a grip on the world, we tended to reject things like we had consciousness and Skinner and behaviorism and everything else. That we should have held on to our intuitions more strongly and said physics is limited. You know, yes, the Newtonian world is deterministic, but we're not. So therefore the Newtonian world is not the end of the story. And I kind of think that as a physicist, I'm looking to see in my physics an echo of the world that I know we live in. And physics is a pale echo, quantum physics is a pale echo of that still, but it's a damn sight better echo than Newtonian physics was. So I've not come anywhere near answering your question, I don't think, except to say that perhaps we need to look back to the wisdom traditions, perhaps we need to look back to that knowledge that's been around for thousands of years about how we should behave towards others. I mean, I think one of the sages is, how should we behave towards others? And he said, there is no other. And the way my approach to it is that what I see in quantum physics doesn't justify what is said there, but it shows me that this is a world that I need to take seriously. I don't know if that's in any way adequate. I think not.
Thank you, Saad, for your prompt. I'd like to invite Manfred in. Hi, Manfred.
Hi. I hesitated to talk because my English is not so good, and now it's becoming complicated, and Germans are well known for making things complicated. So, but I tried, and for me, entanglement is the basis. That means everything is entangled. And what I question is that, or what I'm asking for, are we only looking to prove entanglement because we cannot be conscious of it? And when I turn it around, when I say I start with the whole. So I don't start with interconnectedness. I start with oneness, and when I do that, things seem completely different. And the question I have is, when I look into this room, and I ask, what do I see? And I see the chair and lamp and so on. And I start with that, then I have to ask entanglement. But when I start with the empty space, then I have to start with not knowing. And to see that as a basis. I don't know if it's too if I made it clear.
Well, I think you're very lucky to, as it were, to start with one. The problem, whether it's the problem that I face or it's the problem that, you know, when you're educated in physics, when you go through a physics education from degree to PhD, you know, etc., then you're trained in a particular way of thinking. And it's a very powerful way of thinking, and it's a very effective way of thinking. And if you stop to sort of look at this way of thinking, then it actually doesn't, in my view, it doesn't condition you to see the world quite the way it is. You know, it traps you into thinking that, you know, we are not conscious, that we don't have free will, and we don't have that sort of thing. Because, you know, if you are a young, you know, enthusiastic physicist who's quite good in mathematics and that sort of thing, you spend your entire life in that map of the world, not in the world itself. And you kind of start to confuse the two. And that's certainly something that I was, you know, guilty of, that physics was telling me the way the world actually is, rather than a portion of it and a particular view and approach an approach to it. So I see myself as kind of, you know, digging my way out of this progressively, approaching the wholeness, approaching the one, from a situation of, you know, starting off from a very fragmented approach. And you know, I think some people have commented here that the oneness is very obvious. Well, it isn't to all of us, I'm afraid, because we've been trained throughout our careers not to think in that way. But we're trying to dig our way out of that. And I think I've used the phrase in the company of some of the people in the room at the minute, that I'm trying to use some of the cracks that exist to prise open and get a worldview that is more consonant with that. And I think, coming back to why is entanglement, why the experiments on entanglement, why are they important? Well, because when Schrödinger and others, you know, first brought the notion of entanglement into the physicist's vernacular, it wasn't particularly thought. It was a little quantum curiosity. It's never going to have any practical particular importance. And in any case, you know, these two systems, once they become entangled, they would so quickly become disentangled that it's not going to have any, you know, impact on the world. Well, now we know we can maintain this entanglement over hundreds of kilometers, and that as I said, the technology that's being developed in quantum computing enables us to keep our quantum systems away from the environment, and so study them in more depth. And we know increasingly that there appear to be quantum effects going on in biology. And someone posted a paper, I think in Sutra just the last day or so, about quantum effects going on, it possibly helping migratory birds, something in Scientific American. So I'm always coming back to this notion that we must remember that physics is a picture of the world, but that we are entitled to hold our intuitions about what the world is and what our own existence is in high regard, and we look to converge that with, or the physics should look to catch up and converge with that.
Thank you.
Thank you very much.
Thank you.
This discussion has been more about people throwing cricket balls at me and me trying to put a straight bat at them. I mean, others come in, please, for goodness sake, help me out here.
Well, let's take one more, and then we'll give you a bit of a break, Jonathan. Glenn, would you like to come in?
Well, am I there? Hello, this is Glenn.
Here. Hi.
Yeah, my question is somewhat in line with the last question, and it touches on the question, on the one hand, of our analytical thought process, and maybe at the other extreme, meditation, I would, just postulate right now. So I think, the majority of human existence is an analytical thought process, isn't it? So we kind of pick up some kind of information from our surrounding, and then this information, be it light waves or sound waves, are translated into some kind of abstraction, some kind of idea through our memory, which is, our knowledge. So, so our perception, in a way, is always, heavily biased by our past, our conditioning, our filter that we use to make sense of all of this. And I remember, at least on one occasion, but I think they mentioned it several times, David Bowman Krishnamurti coined this phrase: analysis, equals paralysis. Because an analytical process is inherently limited. And so my question is, on the other hand, meditation is quite a broad and concept, or, I think a lot of people understand something different with meditation. So for me, meditation are like two possibilities. One is just this absence of translating what our sensory input is. So we have our eyes or our ears and everything, like our antennas, and then just refraining from collapsing that wave function into a certain idea and a certain abstraction, but keeping it open, and essentially by that being in the now, being in the present moment of creation, and not going back into this limited interpretation of what is going on. On the other hand, you can also just say, well, I can keep that equanimity and just observe my thought process as a part of this whole action that's going on. So, I can be highly aware of everything that's going on around me, from sound and vision, and also this thought process. But I think for most people, once we fall into thought, it's like a daydream. We kind of become blind. Our sensory import kind of stops, and we're quite immersed in this, in our thought. So we become somehow disconnected with maybe with the greater surrounding that we are in, because I think thought and perception for a lot of people are mutually not possible, or simultaneously not possible. But if you find that bird eye perspective, where you can just observe everything in equanimity, then that may be a different quality. So my question essentially is, where do you see, or where does the audience, or everybody who's participating, where do we see the limits of this traditional analytical thought? Where do we see meditation come in? Do we integrate meditation into our personal daily lives? Especially, after seeing yesterday what the presentation yesterday, where we saw Buddhist monks and whoever going into a certain meditative state, which is obviously has a makes a qualitative difference, for us. So I'll leave it at that. Thanks.
I'll chip in two thoughts, but then I really would like other people to, to come in and broaden this out into a discussion. My two thoughts are, firstly, that skeptical scientists, when they, there's a lot of very, very good and very interesting work going on the science behind, not science behind, sorry, investigating scientifically what is going on in meditation. And that's extremely valuable work that's being done. But very skeptical people would say things like, well, okay, if these sages do have some direct road to understanding the cosmos, ask them to, to have a look inside the atom and tell us what the structure of the atom is. Well, that's kind of like trying to use the wrong tools to do the wrong thing. So I think that's an utterly wrong-headed skepticism there. But the other point I was going to make is actually just shot straight out of my head. So I've just been bold. I missed that particular ball. Someone else answer it. Let me think what it was. I was at the second thing it was I was going to say. You've done me with that. Please, someone else help me out here.
Maybe I'll just follow up.
Because I had a second point to make, and I'm so busy making the first one, I've lost track of the second one completely.
Because I mean, the personal question that I also have is like, how can you be a conduit to this larger intelligence that there is, that, it has created our DNA, it has created our human brain, it has created all this incredible life. I'm not speaking like about, God or whatever that is, but some intelligent process, has been functioning way before we ever developed our thought process. Our analytical thought process. Our analytical thought process has gotten us very far, but it's not the creator of DNA, of brains, of living of life. It's so. I mean, is meditation? Does anybody see meditation as a way to, as a way to tap into a greater into this greater creative harmony? And maybe we'll if you take it as the implicate and the explicit order, we're taking information in, and then we're kind of regurgitating information back out, not as human beings, but the whole system as such. And somewhere there's like an ordering process going on, because we're becoming more complex, we're becoming more harmonious, at least maybe not the human being. So you have to ask the question, where are we going wrong as the human being, and why is why are the other things working quite impressively well?
I remember what my second point was. We've had a series at PARI. Alex has been doing this tremendous series called The Future Scientist. And I've kind of been slightly cowardly because I've not chipped in this thought, but I'm going to do it now because we're among friends, and you won't shoot me down in flames, I don't think. My answer to what the future scientist is actually a shaman. I quite like that notion. I've been fortunate to become quite friendly with somebody. I hope he wouldn't mind me repeating this, but who is in fact a shaman. And I've been having many conversations with him over the past year and a half or so. And he said to me at one point, Jonathan, you're a quantum shaman. And I think that's one of the nicest things anyone's ever said to me, actually. But if we could hold those two sides in balance, the analytical side and the, shall I say, the more contemplative, let's use the phrase shaman to encapsulate that, then the future scientist, the scientist shaman, that's a picture that I personally find appealing. But again, it's just me talking. Someone else, please say something.
Thank you, Glenn. Well, as we're sort of approaching the end of this this session, we only have about 5 minutes. I thought I'd take this opportunity to bring in my granddad's voice. So our friend Jenna, who's behind the scenes, has brought together a few transcripts of her film where she interviews my granddad, F. David Pete, founder of the Power Center. And I thought it'd be a nice way to conclude to read some of this.
Can I just say one thing very quickly before that happens, James? I know I said I'm the only one talking here, but I'm going to do it again. Somebody was very kind earlier on and said something very nice about, you know, my powers of explanation or whatever the blooming phrase is. Many, many years ago, when I was doing my PhD, I picked up one of your grandfather's books off the shelf in a bookshop and read it and loved it. And there was something of a synergy, or maybe even a synchronicity there, because it made me think if a chap from Liverpool could write great books about physics, then maybe I could have a go as well, also being from Liverpool and not having lived too far away from your dad. So, you know, well, that's it, really. You know, so
I mean, I was
here
also
partly because of his inspiration.
Yeah. Oh, well, thank you, Jonathan. So this was filmed about 10 years ago now, where our friend Jenna visited Pari to film and interview my grandfather. And she kept asking him about entanglement, and he would always refuse. He always try to fit in a joke in there to avoid talking about it. So for example, there was this moment where it says, "Oh, can you talk about entanglement?" And he's like, "Oh, well, I didn't really make many notes about this." Says, "Okay, well, what role does consciousness play in science?" And he replied, "Well, theoretical physicists who are conscious tend to do better than the ones that are unconscious." So those are the types of jokes he would say. But he did cave in a little bit and did start talking about non-locality. And he says, the EPR, which stands for Einstein, Podolsky, Rosen, 3 physicists wrote a key paper. They looked at locality, people watching, hearing my voice because the sound waves reach them. They see me because of light reaching the eyes. They're standing or sitting and they feel the pull of gravity. So they're localized. The information comes to them from all over the universe to this location. And that reminds me of watching an episode of Doctor Who with James, that's me. My grandson, one time we were watching this episode with my grandson, and there was this whole idea of some annihilation of the universe. So people are out there and suddenly all the stars disappear. And James, me, said, no, this could not happen that way. Suppose somebody annihilated the universe right now, everything would look the same. After 8 minutes, suddenly the sky would go black because it takes 8 minutes for the light from the sun to reach us. And then after 4 years, we notice another star disappear, Alpha Centauri. And over the next thousands of years, we finally see the Milky Way disappear, but the other galaxies would still be there. So things come to us, we're local. Now, the idea is that there could be something that was non-local. And this was the Einstein, Podolsky, and Rosen thought up. They said, suppose we have a pair of electrons in a single quantum state. That means that they're described by one wave function. Now we know that Heisenberg uncertainty principle. If I measure the position of this, that's fine. They can measure the position, and then the speed, the velocity will be uncertain. Suppose I'm actually doing well as the positions are certain. Well, that's clear. That doesn't violate anything of what you'd expect. But suppose these two particles begin to separate. They go further and further apart. Now, according to the code of quantum theory, if I measure spin down the position of particles, then the velocity of this particle will become uncertain. Or if I, with the velocity of this particle goes and the position of this one becomes unsaid, but how is that possible? How is it possible? It would possibly affect something over there. So why influences, obviously, clearly that is ridiculous. It can't be true. There's something wrong with quantum theory. It's not a complete description of reality, but John Bell took the EPR paper a little bit further when it showed how you could set this up experimentally. And then in Paris, Alain Aspect he took a quantum system separated by several meters and discovered that, yes, this does have an effect on the one over there. There's been no signal traveling between them. So it's a non-local, and that's our world. All of our experiences, our local things come to us, information comes to us, but this is the idea of non-locality, some kind of spooky action at a distance. So it's very counterintuitive. It's a very strange aspect of quantum theory. And then he goes on to talk about Bohm and Einstein a little bit. So he goes, Bohm and Einstein were very, very close to the point where Einstein told someone that Bohm was his spiritual son. But the big argument was brought that Einstein said that there must be an ultimate theory, a final theory, and then we'll know the whole universe. But then Bohm said that underneath that theory, there must be another hidden theory underneath that, another theory. So it turtles all the way down. You'll never exhaust the universe. So for Bohm, it was exhaustible and rich, and for Einstein, it was ultimately and finally the final level of science, and it would finally come to an end. So I hope you enjoyed that. Jonathan, I know we are finishing, so I'd just like to bring it back to you. Any final words to conclude this session and this series as a whole?
Only that I hope it's been as enjoyable for everybody else out there as I've enjoyed all of these talks. And I think we managed to pick a theme which has certainly had resonance with people. So I'm pleased about that, and I'm gratified that so many people have turned up and enjoyed it. So keep an eye out for the great things coming from Barry in the future.
Well, thank you so much, Jonathan. I mean, it was a privilege to, for the Party Center to work with you. And thank you so much for sharing this and for bringing all these wonderful people, yourself included, together to discuss this topic. And of course, thank you to everyone here who joined us for the past 3 weeks and discussed the topic of entanglement. Thank you for your questions, your contributions, and your messages in the chat.
And thank you, James, for sharing them all so well.
Oh, well, thank you, Jonathan. Yeah, so this has been really wonderful. Just as a quick reminder of our future events, we do have on Wednesday this session with Rupert Sheldrake to celebrate the anniversary of his controversial TED Talk, which was then removed from the TED YouTube channel. We do have other events coming up, so please look on our website as there will be announcements soon, or of course, subscribe to our newsletter. But if you're bored in the meantime, of course, we do have our YouTube channel where we do have our past sessions, and we do have many more of our recorded sessions on our website. So yeah, thank you, Jonathan, again. Thank you, everyone, and we'll see you again soon here at the Party Center. Bye-bye.